Hello, everybody. This is Coach Mindbauer for AP PreCalculus. We're here in section 4.6. We're going to do day 2 of this. We're still focusing on conics, but we're going to focus more on hyperbolas. And then we'll get to some other conics too as well in this section with our worksheet. So let's talk about hyperbolas. There's two types. There's horizontal hyperbolas. There are vertical hyperbolas. And you can look at all those properties right there, which pretty much align with a lot of ellipse, but at the same time, some stuff that's very different. You can look at all that stuff yourself. I think it's easiest if I were to go through this. And then I will kind of answer all these questions or hit all of these as I go through this first example right here. So for example 1, we're going to graph this y squared minus x squared equals 1 and answer the corresponding information. Okay, so for this right here, whenever our y is first, that's going to give us a vertical hyperbola. You can kind of see that up there in that little box right there. So whenever the y is first, we have a vertical hyperbola. So this is going to be vertical. Okay, we are centered at 0, 0. Make sure that our x's and y's correspond. There's both 0, so it's a little bit tougher to make that argument. And yeah, let's just start right there. So it's centered at 0, 0. Let's put a point right there. That's actually on the hyperbola, but you'll see what it looks like. All right, vertices always go in our, not the bigger one, but real quick for 9 here, we're going 3 up and down, and we're going 4 left and right. So for an ellipse, the 4 matters because it's larger than the 3. For hyperbola, we just care about what's positive here. So I'm going to go up 3. And this is going to provide me with my vertex right here because we are a vertical hyperbola. So my vertices are always in the direction of the positive variable. So that since y is positive, we're going in the up and down. So we're going to go up 3. So it's going to be 0, 3. And it's going to be 0, negative 3. Oops. All right, my pen is no longer working. What else is new? Okay, so then we also have these things called covertices, and they're just there. I'm going to actually draw them in like blue just so you can kind of see them. So I'm going to go in this direction here, and that was not at all what I was expecting. What just happened? We're going to undo that. Here we go. And these have to do with our asymptotes, which I'll get to momentarily. Okay. Foci. For the foci, you're going to add the a squared and b squared together. So this one, if I add the foci together, I'm going to get c squared. Oh, boy. This marker, this. There we go. Oh, boy. That doesn't look great, but whatever. A squared. Oh, geezers. It's 9 plus 16. So now we're adding these together. All right, you're not working anywhere, are you? There we go. Okay, so which gives me a c is equal to 5. So we're going to go 5 in each direction. So I'm going to go, again, this is not really on the graph, so I'll keep it blue. F for foci. I'm trying my best here, I promise. This is just being really difficult. It's like my child being difficult. Oh boy, like my child, difficult. Come on. Come on. That's how I treat my children too. Come on. You can make the F. There you go, F for foci right there. Okay. So my foci are at the points 0, 5. And you know what? It'd be cool if I just put plus or minus 5 right there. Anybody bother anybody? Nobody's bothered? Fantastic. Equation of the asymptotes. This is when we look at the change in the y over change in the x. And so in this case, it's going to be change, and which is going to be 3 is the x change and y. Sorry, 3 is the y change, 4 is the x change. I'm just scrolling up here to kind of show what the m represents. So the equation of the asymptote is right there at the bottom of the box, as you can see. So because there's no k and there's no h here, I'm just going to do y equals, and there's two asymptotes, so plus and minus, and then this is going to be x, because there's no h and k, the m value, and this is what m is equal to. So our change in y is going to be, for this case, 3, because our y's are changing by 3 because it's 9. And then our x's are 4. So that's our slope, okay? So if you go from our center, you're going to go up 3 over 4, which is going to line up nicely with the blue and the red. And then we're going to go from here to here. And then there's your lovely asymptote. That's the positive asymptote. And you gotta go the other direction. And here is my other lovely asymptote. It's dashed because it's an asymptote. Okay. And then we're going to connect our vertices and kind of go out and hug those asymptotes a little bit. Make this parabolic shape. It's not a parabola though. And then it's going to go that way, and we're going to go this way. So it's like the opposite of an ellipse. Ellipse, you just draw inside. Hyperbola explodes onto the outside. So that's what that looks like. Okay, so this domain for this one, this domain is going to touch all x's. So we're going to go from negative infinity to positive infinity. And our range here is going to go from negative infinity. That will touch negative 3. And we'll go from 3 to infinity. Oh, boy. Oh, boy. There we go. Oh, the next page isn't even loading yet. Oh, boy. This is going to be a disaster of a video, I think, because I don't even know if that page is going to load in time for us. All right, so that's example 1. Any questions? No, this is what I do in class. I just like stall, but everything's loading. This is a great oofarino here. I'm going to just hit refresh, hope for the best. Maybe everything will load. Maybe. We're just going to sit here and let this thing load. So, how was your weekend? Good? Okay. This is what I do in class. Oh, you did that this weekend? Oh, that sounded so fun. I'm so jealous. Oh, yeah. Oh, what did I do? Not much. Okay, there we go. It loaded. Okay, so we're going to go ahead and graph this right here and answer this corresponding information. I can tell you right now that this is a hyperbola because we have an x squared and then a minus a y squared of some sort. So if you ever have an x squared and a minus y squared, that will give us our hyperbola. So here we go. We're going to need to complete the square here. I'm going to organize everything. So I'm going to get my x's together. So I'm going to get x squared minus 2x together. Let's get my y's together. Minus 4y squared plus 16. And let's throw that 19 on the other side. Sorry, 16y should be right there. Okay, now I'm set up to complete the square. So x squared minus 2x plus blank minus 4 times y squared. If I take out a negative 4 there, it becomes minus 4y right in here plus double blank. That's going to equal 19 plus a blank, and then minus 4 times whatever my double blank is, just to balance everything out. And again, this kind of mirrors what we did for the ellipse in terms of completing the square here. So inside the x parentheses, half of negative 2 is negative 1, and we're going to square it, and that gives me a positive 1 here and there. And then for the double blank over there, we're going to go negative 2 and then square it because it's half the b term. That gives me a 4 there and there. And I believe that gives me a 4 on the right-hand side. So I'm going to get x minus 1 squared minus 4y minus 2 squared equals 4. because 19 plus 1 is 20, minus 4 times 4 is 16. So we get 4 on that side. Divide everything by 4, and I'm going to end up with an equation of x minus 1 squared all over 4 minus y minus 2 squared over 1 equals 1. And then here we go. We can hit up everything just from this. So this is going to be horizontal now because the x is in front. My center is at 1, 2. Oh no, it's acting up again. One, two. I'm going to plot that point. 1, 2. Vertices. So now the vertices, because it's in the front, we're going left and right too from there. So I'll label this as the V going this way. That's also the V. Okay, so what are those vertices? They are negative 1, 2. And 3, 2. Okay, if I do co-vertices, it's going to go up and down 1. Not really that important to label the co-vertices, but they do kind of help us with our asymptotes when we get there. Foci, add those two numbers up. So c squared is equal to 4 plus 1. So c is going to equal root 5. Root 5 is between 2 and 3. So I'll do the foci in blue here so you can see it. But the foci is going to be the blue ones just on the outside. I'll label that. I'll label it with a F so you can see it. Those are foci. So what is that in terms of coordinate point? The height's still 2, but it's going to be negative or 1 plus and minus root 5. I'm going to root 5 in each direction, comma 2. So what's the equation of my asymptotes? Well, it's going to be y minus 2 because that goes in front equals, oh boy, behave, you pen, y minus 2 equals plus and minus slope. I'll do that in a second. And then x minus 1. If you notice, I'm kind of just copying and pasting the numerators, not the squareds, of course, into my equation of asymptotes. I just kind of copy and paste where those go. And then the slope, so the change in y over change in x. This is taking forever. So the y is changing by 1, the x is changing by 2, so it's going to be plus and minus 1/2. So I'm going to draw these. I don't know exactly how accurate that is. It's kind of close because I know that slope is 1/2. Oh yeah, my head has to go sideways to get these right. Again, I'm trying to get it through where those corners would make. And then the vertices are here, so I'm going to draw this thing out and connect it with the asymptotes. Okay, so there is my hyperbola. Domain, in this case, this domain is restricted. So we're going to go from negative infinity until negative 1. And unite that with 3 to infinity. But our range, it goes up and down forever. This is, oh boy. Oh boy, let's hope this thing can last through the whole video here. There we go. All right, last two questions are just kind of giving us a description. Let's go ahead and get the equation of the hyperbola. Again, I think sketching it is our best bet here. So here we go. Example 3, find the standard form of the hyperbola with a center at the origin. So if I sketch this, the center is at origin. Our vertex is at 0, negative 12, which is down here. The vertex there. And focus is down here at negative 13. So this is negative 12. Oh boy. Oh boy, we're struggling. So negative 12 is right there, and negative 13 is right here. What does it tell us? Well, I know this is, since this is going up and down, this is a y squared. If you know why it does that, my stylus just makes everything into lines. Please let me know in the comments. Dealing with this for 4 units now, and it just keeps happening. Okay, since that's the order for me, I need to know how far down I'm going. Well, I'm going down 12, so I'm going down 12, square it, 144 in the y direction. Okay, and then I don't know how far left I'm going, but I do know my focus here is 169, and that is equal to 12 squared, which is 144, plus, what is this called, a squared or b squared? I want to be consistent with your notes. I don't know if it flip-flops. So the a always goes with x. Okay, got it. So plus a squared. So a squared is equal to 25. So this is 25 right there. Okay. Last one. Find the standard form of the hyperbola with a center at the origin. Super nice to have that center at the origin. Vertex is now at 8, 0. So we're at the origin, and now we're going to be a horizontal. Got to figure everything out. For the x's, I know I'm going over 8. So if you square it, that's 64. So I'm going left and right 8. But how much am I going up and down? Well, if my slope of the equation is 1/2, in order for this to work, this would have to be 4, because 4 over 8. Where did my pen go? Oh, yeah. Oh, geez. Oh, geez. So 4 over 8 is equal to 1/2. So I know this has to be 4. So if that's going to be up and down 4, it's going to be 16. So that will give us our equation of our hyperbola centered at the origin. And there we go. And that's going to wrap everything up. Do not forget to like and subscribe.